Hello everyone. Today I'll be presenting on real-time operating system Zapier as my term paper. Firstly, let's discuss about what RTOS. RTOS stands for real-time operating system. It is a specialized operating system for time-sensitive and real-time tasks. So about RTOS, it is highly reliable and low latency in embedded system. RTOS ensures deadlines are met even under high processing loads. So this is about RTOS. Talking about different type of RTOS, we have three type of RTOS: hard RTOS, soft real-time RTOS, and firm real-time RTOS. Hard RTOS focus on strict management of the deadline. It implies the necessity of the beginning the execution of a specific task at a concerned time. So it is very strict in time constraint. The second is soft real-time RTOS. Soft real-time RTOS could adjust with delays due to specific cause in the operating system. It could allow a small amount of time delay. So it is not so strong in concern about time restriction. And the third is about firm real-time operating system. Full real-time operating system also emphasize compliance with deadlines, although delay in the meeting deadlines would not affect the operation. So basically talk, these are the three different types of real-time operating system. Now introducing JPR. JPR is a real-time operating system and it is a lightweight. It is basically known for its lightweight and it is an open source operating system and highly known for its security. So discussing over here, why JPA? The firstly, it's open source. It is backed by a community under the Linux Foundation. The second time is real-time performance. Optimized for devices with limited computational power such as microprocessor and small devices. Resource efficient. Optimized for device with limited computational power and such as microprocessor controller and small IoT devices. It is very energy efficient for the gadgets which are run by the small batteries. Third, it is known for super flexibility, worked with all kind of devices. That's why JPR is chosen. Talking about JPR's origin, as I told, it is developed by Linux Foundation for Internet of Things or IoT devices. It inherits some features from prior projects. And talking about the flexibility of RTOS, I mean the JPA, it supports multiple architecture, ARM, X6086, RISC-B, and it competes with free RTOS and BX works in this area. Talking about the architecture of RTOS, it is highly modular and lightweight for resource constraints devices. And it is selective complication for effective memory use. Seeing at the architecture, we can see at the down, it has Linux, it has a kernel. It consists, contains radio sensors, crypto or flash for taking the data. It contains power management device. It contains kernel schedulers which schedules the operations. It contains now on top of the kernel we have OS services, which is like a driver which does device management, thread management, cell, Bluetooth, and etc. as shown in the figure. And on top of that lies application services. So this is the overall architecture of Zapier real-time operating system. So how Zapier works? First, it does is task scheduling. It rate the monitoring. it works with a monitoring schedule. It checks which has the earliest deadline, and based on that, it tags the schedule. The second is counter task communication and synchronization. Employees mechanisms such as semaphores, message queues, and even flags is used. The third is resource allocation. It adjusts memory and processor time based on task priority dynamically by the kernel. And the third is interrupt management. Prioritize interrupt handling at hardware level. So in this way, the JPA works. The third is talking about the key components of Zapier. The first one is kernel, the second is drivers, the third is libraries, and the fourth is subsystem. So kernel is the core of Zapier, responsible for managing system resources and ensures real-time performance. And the second one is drivers. Drivers in the Zapier provides the interface between the hardware and the software. Libraries, basically, JPR are reusable codes modules that provides utilities, functions, and middleware supports. It contains standard library, file system, logging, debugging. Talking about subsystems in JPR, JPR are high-level components that offers additional functionality, often integrating multiple drivers and library. So are the key components of JPR. Talking about the challenges of JPL, limited high performance capability, but perfect for small devices. Complexity in multiple threading. JPL is has a high complexity for working multi-threading tasks. Resource requirement for AIs and AI application, but its application is emerging. So these are some challenges faced by the JPL. Now, talking about its applications, where the JPR operating system it is used in monitoring systems, as you can see in these images as well. The secondly, it is used in factory automations, and third is like it is used in smart home devices, and fourth is wearable devices like smart clothing and smart watches, sport watches, fitness tracker. These are some of the applications where JPL is used. Now, talking about companies and organization involved, it is managed by Linux operating system, a Linux community. Sorry about that, and contributed technically and financially by NXP, Intel, and Nordic Semiconductors. And the companies which have adopted JPR real-time operating systems are Samsung, Google. What next for JPR? The first main thing is getting smarter with it. With this growing technology and the system being more dependent on higher, JPS needs to get more smarter to be compatible with AI. The second one is helping gadgets process data locally, known as edge computing. So these are what uh, next step for JPR. And at the last, for the conclusion, JPL, it is known for its secure modular real-time operating system for IoT and embedded devices. It is known for its powerful, efficient, and protocol support. It highlights open source in innovation in scalable embedded solutions. And JPL is working on its continuous development, means being compatible with AI locally handling the the system operations. Thank you. This is overall discussion about JPL.